Hello my esteemed viewers. In this tutorial we will discuss clearly the implementation of linear search and binary search. As you may recall, we have already covered some of the manipulations of an array, and we are also taken to understand as to why manipulations in an array is required. When we manipulate an array, some important information will be driven out. Among the several manipulations, we have discussed initialization and duplication, accumulation, reversing of an array, arithmetic operations on an array, sorting, and the two famous sorting techniques, bubble sort as well as selection sort have been discussed in the previous tutorial. And in this tutorial, we will discuss two predominant searching techniques. There are two searching techniques that exist: sequential search or linear search and the binary search. And for a question as to why we need to search in an array, the answer is very simple. We tend to search an array to find the presence or absence of very important element or significant element or an element which is unusual. We will consider this example. This is an example of an array of 7 people, the weights of 7 people who are in the enlisted panel of selectees in a maybe army recruitment, let us say. These are all the weights of 7 people, and we want to search, is there any weight of 85 kg in the list of entrants or list of selectees? 85 is there very much, and this becomes a predominant figure among the weights because it is something unusual or something significant, let us say. And in order to find this in linear search, we need to compare this elemental key value with all the elements. It should be compared with the first element, the second element, the third element, so on and so forth until it is found. If it is not found, we will have crossed the last element also. So this linear search faces 3 scenarios. Number 1, key is in the very first place. This is the best case of the algorithm. Okay, there will be only one comparison that is being done. And if the key is present in the last place, if the array contains 1000 elements, 1000 comparisons are a must. It should be done essentially. And if key is being absent in the array, then also 1000 comparisons are to be done. Therefore, linear search is little tasking. But anyway, it will definitely identify if at all the element is present. And it is also possible to drive out in which position the element is present. So we will take an example number 12. This comes as a cumulative example for our tutorials an array. This program does linear search on an array and the elements are all unique. That means all the elements are different. Therefore, if at all a key exists, it will be only one key. The key may be present or key may be absent. Anyway, it will be only one. And array is declared consisting of 100 elements. I is for running the loop. Key is the key element that is to be searched. NE for number of elements, and position in order to drive out, in order to echo in which position the key is present, if at all key is present. Found is used as a flag, and to begin with, found is used to represent that key is absent in the array. This is an assumption, therefore found is equal to 0. Anyway, we have been told that the variables like this that are flags will carry only 2 values, that is binary values, boolean values, either it is 0 or 1. If the thing on checking becomes true, found will become 1, otherwise it will remain to be 0. And it is also used over here. You will see when I discuss this program, you will see found will be finding its best utility, because we can, making use of this found, we can also lessen the number of comparisons. How many elements? NE. enter the elements. The user will, upon looking at this particular prompt, the user will start entering the elements. Number of elements will be equal to NE. He will enter, let us say, 10 elements or 50 elements. Enter the key to be searched. He will also enter, the user will also enter the key that is to be searched. And linear comparison starts over here, linear search starts over here. For I equal to 0, I less than NE, I plus plus. If array of I equal to key in any position, if the key is found in the ith position, let us say 6th position, the position will become equal to 6 and found will become equal to 1, and we are going to break, the control is going to break because there is no fun in continuing our search. Let us say in a case, if the key is found in the very first place, the position will receive 0, found will become 1, and there is no question of comparing furthermore. Okay, therefore by including this found, that is a flag, we have increased the efficiency of linear search. If found equal to 1, the element is found in the location and the location will be printed, else the element is not found. And we will also do another program, that is what is this? This is another example. In this program, find the searching on an array elements that are not unique. Elements here are not unique. That means there are repetitions of elements. Therefore, it is possible to guess the key may also get repeated. It also finds the positions where the keys are found. If keys are found in multiple positions, if there is a repetition of keys, then also it will find. Okay. Therefore, the declaration goes like this: array, key, and k. This is the index which will serve for this positions array. This positions array will contain various positions at which keys are found, because this is an array containing non-unique elements. Okay, with repetitions of elements. Therefore, possibly key may also repeat. How many elements? The user will enter the elements. Elements will be entered one by one. Enter the key to be searched. The user will also enter the key. Then k is set to 0, because this is to accumulate the positions where the keys are found. Multiple keys are found. For I equal to 0, I less than NE, I plus plus. And as far as this comparison is concerned, there is no need of a flag, because we have to go until end, because there may be repetitions at the later part of the array also. Right? If array of I equal to key, then position k plus plus equal to I. Position k in the first iteration, if for the first finding k is equal to 0, therefore position 0, the 0th position of the position array will contain the location at which the key is found. Let us say that in the first place, key is found in the original array at 6th place. The position of 0 will become 6. In the 12th place it is found. In the second, in some other cycle, it will be taken as position 1 equal to 12, like this. So this index of this array, the subscript of this array will also be incremented. How long it will be incremented? As long as the key is found in different positions. Okay. Anyway, there is no question of adding the positions of this key beyond the number of elements. Anyway, this will have overall control of reaching the end, and this will pick up only the positions where keys are found in multiple copies. If k equal to 0, if there are no keys present, k will remain to be 0. Therefore, if k equal to 0, the element is not found. Otherwise, printf element is found in. Okay, so position array will bring in the position. Let us say it is found in the 6th position. Position 0 equal to 6. Okay, position 6, position 7, position 8, something like this. Okay, it will be printed in an appropriate manner, the positions where exactly the keys are found. So we will discuss about binary search. Binary search is a very efficient searching technique, proved to be a very efficient technique, because every iteration the array will be hauled into two parts, and only one part of the array is considered, wherein it is guessed the key may be present, wherein there is a possibility of key being present. But the primary condition for this binary search implementation is the array is to be sorted. say in ascending order. The algorithm sets out two probes, one is first, the other one is last. The first and last will find their respective positions different in different iterations. Let us see how exactly it happens. So as a second step, it finds the mid position as first and last, first plus last divided by 2. Let us say first, in the first iteration, first will be equal to 0 and last will be equal to, let us say, 15. If there are 16 elements, okay, the last will be 15. Okay, if there are 15 elements, last will be 15, and 15, 0 plus 15 divided by 2. It will be giving us 7. Therefore, every time it calculates the mid position, it compares A of mid, the value of the element that is found in the middle position, with the key. It compares the value of the element present in the middle position of the sorted array with the key. If key is greater than A of mid, that is, if the key is greater than the element present in the mid, the left portion of the array is not at all considered. It shifts the first probe named as first to mid plus 1. So it is a lateral movement for the first. It will cross the mid also because key is greater than A of mid. On the other hand, if key is lesser than A of mid, it shifts the last to mid minus 1, leaving behind the right portion of the array. Therefore, if any of the conditions are met with, the array will be hauled into two pieces. Therefore, the name binary. Algorithm anyway eventually has to stop. It works iteratively, all right, but it stops when the key is found. So this is understood. This goes without saying, which happens when key equal to A of mid. When key is not found, okay, the key is not found whenever first becomes greater than last. Okay, this is a very fictitious situation. When first crosses the last, the probe named first crosses the last in terms of its value. The meaning is the key is not found. Okay, we will better understand this with an example. So in order to reinforce our understanding on this famous algorithm, let us consider this array. You can see that this array is sorted in ascending order, and there are 7 elements. In the first, let us search for the key, which is equal to 85. Of course, it is not present. Key is not present. Anyway, let us see what happens. First is set to 0, last is set to 6, and mid will be equal to, in the first iteration, mid will be equal to 0 plus 6 divided by 2, mid will be equal to 3. Now, so this is the position. Since key is greater than A of mid, there is no fun in continuing with this particular portion of the array. The array is going to be into two pieces. Therefore, the name binary. And we will, in the next iteration, we will be considering only these 3 elements, which is on the right side portion of the array. Now, first iteration is completed. Okay, now the first will be shifted to over here, and last will remain to be here only. See, first equal to mid plus 1. Mid is 3, so first will go to 4, first will come over here, and last remains to be at 6. Mid will become a new mid. It is 4 plus 6 divided by 2, it is equal to 5. So mid will come somewhere over here at 74. Now again, key is greater than 74. Key is greater than A of mid. Therefore, first will be shifted to over here, mid plus 1, and last will remain to be 6 only. You can see first equal to mid plus 1, that is 5 plus 1, that is equal to 6, last equal to 6, therefore mid equal to 6 plus 6 divided by 2. Okay, this throws out a peculiar situation. If the key is present in the last place, then also it will be found, because we are going to the algorithm is going to put up a question like, if A of mid equal to key, then key is found. Okay, this is the middle position. This is the only element that remains, and that is the middle position. Now, once again, it goes, because it is not found, because A of key is not equal to A of mid, it will go for the next iteration. Then first will become equal to mid plus 1, that is 6 plus 6 in the previous cycle, it is 6 plus 1, 7. First will become 7, last will remain to be 6. Therefore, first becomes greater than or equal to last. This is a clue that binary search implements. Whenever first becomes greater than last, the meaning is the key is not found. Let us see what happens if we search for a key which is equal to 20, which is also not there, okay, which is also not there because it is lesser than 23, and this is the array once again. Then we will calculate first and last. We will put up first and last as usual, and we will calculate the mid, and mid is over here. And since the key is lesser than a of mid, there is no place for this portion of the array. Okay, it will be hard over here, and this portion is taken out. This portion becomes redundant. The data size reduces to half. This is the main advantage of binary search. Okay, now second iteration starts. Since last will come over here, first is here only, last will become equal to mid minus 1. Earlier, in the earlier iteration, mid was 3, it becomes mid minus 1, that is 3 minus 1, 2. First remains to be there only. Then there will be new mid that is being calculated. It is 0 plus 2 divided by 2, that is equal to 1. And this is the middle position. This is the element in the middle position. This is still greater than key. Still greater than key. Therefore, the last is to be shifted furthermore. There is no place for this portion of the array because key is lesser than a of mid. Once again, last will become mid minus 1, that is 1 minus 1, 0. In the earlier iteration, mid was 1, 1 minus 1, 0. First remains to be 0 only. Mid is also equal to 0. Then once again, this is the only element. This is also not equal to key. Therefore, mid will be further reduced in the next cycle. Okay, so last will become mid minus 1, that is 0 minus 1 minus 1, and first equal to 0. Therefore, first is greater than last. First is 0 and last is minus value. Therefore, first is greater than last. And this is sufficient enough for the algorithm to stop because it is a fictitious situation. Occurs whenever key is not found in the array. Okay, key is not found. So we will therefore we can consolidate our idea. If at all key is not found in the array, the first will become greater than last. Okay, first will become greater than last. Okay, if key is found, then then a of mid will be equal to key. The middle element will be equal to key. Okay, this program does binary search on the given array of n elements. It also finds the number of probes. How many probes we have conducted, how many probes before we got out with an element, key element, or before we said the element is not found. Okay, how many probes, how many middle positions being calculated, that is also another meaning. Integer array 100, ne, I key, mid, first, last, temp, np. Okay, temp we have because we will arrange the array in ascending order using bubble sort, and then we will proceed with binary search. Therefore, we have the elements of bubble sort algorithm also, the parameters involved in bubble sort algorithm also. Enter the number of elements. Okay, this is a guidance given to the user. Enter the elements. Then bubble sorting is done. Okay, bubble sorting, I think you may recall bubble sorting. Bubble sort, the key logic with bubble sort is n minus 1 iterations and n minus 1 minus I passes. Okay, so this is being done, and after the completion of these two for loops, what we get is a sorted array. Array after the sort, in order to check whether we have sorted, we have printed the array over here. Then enter the element to be searched. We will take the element. So we will set the probe last, ne minus 1, first to 0. Number of probes not yet happened, therefore it is equal to 0. Do mid. We don't know, we have to do with the do while loop only because we don't know when exactly a of mid matches with key or when exactly first will become greater than last. Therefore, at least one entry is to be given. Therefore, do while loop is the candidate iterative construct that is to be used in binary search. Mid equal to last plus first divided by 2, np plus plus. As soon as we calculate the mid, it is an understanding that we are trying to probe. Okay, so we will exercise this option. If key is lesser than array of mid, okay, if key is found to be lesser than the element that is found in the middle position of the sorted array, then last will become mid minus 1. Okay, and if key is greater than array of mid, if this becomes true, then first will become mid plus 1. This kind of iteration, this process is to be repeatedly done till any one of these conditions becomes untrue. Any one of these conditions becomes untrue. Okay, key not equal to array of mid. Okay, first lesser than or equal to last. Okay, if this is true, it will be executing. If both of them are true, it will be executing. If any one of them becomes untrue, the entire expression becomes false, therefore control will come out. Okay, the control may come out because of two reasons. Number one, when key becomes equal to array of mid. Number two, when first greater than the last. Okay, so when we come out, we will question this. If key equal to array of mid, printf element is found. Searching has taken %d probes. Okay, that is with the NP, number of probes. Else the element is not found. We have exercised with a simple example. Enter the number of elements. Enter the elements. We have entered 12, 33, 45, minus 2, 10. And we have implemented bubble sort over here. After the sorting, array after sort, minus 2, 10, 12, 33, 45. Enter the element to be searched. It is 12. We have entered. Element is found. Searching has taken 1 probes because the first mid itself matches with key. Key is also 12 and it is available over here. Therefore, number of probes it has taken is only 1. So with this, I think my respected viewers are very clear about this binary search and linear search. And one thing to be remembered is linear search involves huge number of comparisons, in the worst case n number of comparisons, while binary search reduces the number of comparisons, okay, drastically. This is a very important point, but it comes with the cost of array being presented only after sorting. Okay, much of the comparisons will have been expended when we implement either bubble sort or selection sort. It is recommended that we should always implement selection sort, because as we know, selection sort will consume lesser number of comparisons when compared to bubble sort. So with this, we will come out with the next tutorial with merging an array as the last manipulation. Until then, bye.